Mr. Ablatdyin Musaev is from the Academy of Research of Uzbekistan, and he's been studying Aral Sea for a long time now, and his presentation today is regarding the Aral Sea. I'm the translator. My name is Tariq, and example of terminal lake, fate of Artemia presence by Ablatdyin Musaev. The Aral Sea, okay. Aral Sea once the fourth largest continental water body in the world. From 1900 to 1960s, the surface area of Aral Sea was 69,790 square kilometers. Its maximum depth was 69 meters, and the volume of its water was about 1,056 cubic kilometers. The average salinity of the sea during the natural period was 10.3 grams per liter. Due to a sharp reduction in water inflow since the second half of the 20th century, its area has decreased by more than 13 times. The volume of water has decreased by 20 times, and the water level has dropped by 33 meters. The sea has divided into two reservoirs, the small Aral and the large Aral. As a result, this is on Uzbek side. As a result, the mineralization of water in the large Aral has increased more than 19 times, reaching 197 grams per liter to date. We are witnessing one of the most significant transformations of the ecosystem of one of the largest lakes in the planet. So here you can see currently the level of Aral Sea at 23 meters. This is data from Hydrometeorological Station of Republic of Kyrgyzstan. An overall decrease in the sea level up to date is 33 meters. So you can see here different years. In 2022, right now it's 1957 sea level. Long-term dynamics of mineralization of the big Aral Sea. Here you have the western basin, the eastern basin. Right now the western basin, the salinity is 198. In the eastern basin, it dried up in 2009. Average monthly water temperature of the Aral Sea, you can see from 1941 to 1960s and from 1961 to 1982. We took this data from the literature. And from 2000 to 2018, this is our observations. You can see on the month of April, the salinity rises rapidly. That's because the water is shallow. That's why the temperature rises very quickly. Because it was more in the previous years, the water body was higher. The temperature didn't rise as quickly, and you can see that in the November it cools down very fast too. Okay. This is the annual water inflow from Amudarya and Sirdarya. Those are two main rivers that feed Aral Sea. And you can see that by 1994, there's no inflow to Aral Sea. Here, the Aral Sea dried up. Its classification is a sulfate type reservoir. And this is from the research of Botnik and Chisaeva. The waters of the Aral Sea increasingly approach the chloride type, similar to that of ocean waters. Large-scale studies of the Aral Sea have been conducted through international research projects such as NATO, Artemia colonization of the Aral Sea, hope for a dying ecosystem. And the other project is economic and ecological benefits from the sustainable use of Aral Sea Artemia resources. Abroad, the Aral Sea is primarily studied by the Institute of Oceanology of the Russian Academy of Science from Moscow and Zoological Institute of the Russian Academy of Science, primarily focusing on the small Aral Sea in Kazakhstan. As salinity in the Aral Sea increased, the structure of the zooplankton community underwent significant changes, leading to a shift in a dominant species and a sharp decline in biodiversity. Artemia was not initially known in the open part of the Aral Sea. though it was documented in the salt lakes of the southern Aral Sea region. During the 1980s and 1990s, Artemia was observed in shallow coastal waters separated from the Aral Sea and in small lakes on the eastern cliff of Usturt Plateau. In October 1998, Artemia was recorded in the pelagic zone of the Aral Sea near the northeastern shore of Возрождение Island. However, the Artemia population was unstable at the time. The destruction of the dam separating the big and a small Arals led to an influx of a significant amount of desalination water, 20 grams per liter, and the fish species Atherina bayeri into the big Aral. Consequently, Artemia was observed in the Aral Sea in 1999. Since 2000, Artemia has become a permanent and dominant component of the plankton, comprising more than 99% of the total zooplankton biomass. It is possible that Artemia was present in the Aral Sea at very low salinity from the start of the sea levels declining since 1960s. However, only when salinity exceeded 60 grams per liter did the Artemia population stabilize. Fish were present in the large numbers, even at salinity levels up to 63 grams per liter, and likely controlled the Artemia population. Since 2002, with salinity levels exceeding 75 grams per liter and only isolated survival of individual fish species, the Artemia population has no longer been controlled by vertebrate predators. Only females of Artemia were encountered, identifying the Aral brine shrimp as Artemia parthogenetica. So plankton sampling sites on the Aral Sea, you can see here on the map. Markers marked in green are sampling sites in 2005 and 2008. Marks marked in yellow are sampling sites in 2000 and 2024. This is number of expeditions that has been done by Academy of Research. This figure shows the diagram of the presence of cysts in nauplii of Artemia in Western Aral Sea from July 2001 to August 2010, calculated as units per liter. This diagram of the presence of the cysts in nauplii of Artemia in the Western Aral Sea from July 2011 to August 2018. The maturation time of the first generation is about 40-45 days. Juveniles appear in May. The first count of sexually mature females can be made in early June, although they can already be observed in early May. The number of sexually mature females in the study period was within 0.01, 0.19 pieces per liter. Quality of Artemia cysts from the Aral Sea. The measured length of Aral Artemia nauplii at the instar-1 stage after 24 hours was on average 0.49 millimeters, the result of measurement of 500 individuals from different collections. And the diameter of the hydrated decapsulated cyst was average 0.247 millimeters. It's 1,000 cysts from different collections were measured. Dynamics of the Artemia cyst collection in the Aral Sea, Uzbek part from December 2010 to March 2024. In 2010, you can see that it's only 9 tons, and in 2020-2021, there was 2,000 tons. In the previous year, they harvested about 1,500 tons. Collecting Artemia cyst samples on the shore and from the water surfaces, winter cysts remain in the water column and in certain coastal areas throughout the winter. In the spring, environmental conditions, primarily water temperature, reach levels suitable for the onset of metabolic activity. This increases the metabolism, inevitably result in a hatching of cysts. The hatched brine shrimp nauplii go through a series of development stages, ending with the formation of sexually mature adult specimen. In the case of Aral brine shrimp, 99% are female. Diagram of the presence of adult female Artemia in the western Aral Sea in May and June of 2002 to 2017, calculated as units per liter. Comparison of reproduction methods by cyst laying and viviparity of the Artemia population of the western Aral Sea. So the red is, that's the live birth. You can see in July the live birth increases. In October you can see the blue line, cyst production because of the winter. Average long-term values of seasonal dynamics of biomass. The western and eastern basins. In the western, you can see that it's only 4.5 maximum, where in the eastern basin you have about almost 35. But the eastern basin has disappeared now. Taking the fact that the salinity has risen in Aral Sea, we don't know the future, what it holds for us. That's why there is a GIZ regional project that we've worked with, together with Patrick Zorgelis. Mr. Zorgelis came to our site, and we are because here I have to put a small video that we made, and if you give me a second, I have to type in the... Artemia is one of the main exports that we have in the Aral Sea region. It creates a lot of jobs for the local population because we hand harvest it, and because the Aral Sea is the salinity is rising, and we have a lot of degraded agricultural land that's very saline. We are working with the GIZ and Patrick. Patrick came in 2022, and he has checked the Aral Sea. He took the samples. We measured the salinity in the Aral Sea. In predictions were that if there's no fresh water inflow to Aral Sea, we might lose the resource that we have, which is export. And aquaculture is not developed that much. Patrick came with Mr. Nasser Ah back then. We talked to the local government. We told them that there are opportunities where they can provide jobs with the small ponds. That's why GIZ decided to send 4 of us to go to Vietnam to study with their experience in the artificial pond production of Artemia. We spent there about 1.5 months. We have a lot of artesian wells that are very saline. That's nobody using, so we are not competing for fresh water for agriculture. And lots of artesian wells that have been there for 60, 70 years that are going outside and nobody's using it. And the other source is a collector water, where agriculture, they wash the saline water, the saline lands. So there's been a lot of work for the past, 2 years. We've been analyzing different types of waters, ponds. In 2022, we chose a pilot project. A specialist from Vietnam came to teach us. We introduced Artemia franciscana to this area, and it has survived. But there were some difficulties that we had. We couldn't keep the salinity in the water because the soil type we chose, the salinity went down to underground. So we had to choose a different area where we could keep this salinity in the water. So after a lot of searching for soil, we worked with the innovation center that we have. We found this great place, very saline, natural salinity, 17. There's a lot of hectares here. And the water that we have here, you see, is a collector water. So nobody's using it. It's unused water, and you can see the salinity that's spread around there. So we analyzed the soil type. We were sure that we could keep the water, that it wouldn't go down, and we built ponds there. Here we're testing the clay type. The clay has worked, and the digging procedures have started. So the Artemia is growing there right now. This is Franciscana. Right now we are getting, we have four different pond types with linings, with bentonite lining, with underground water. We're testing different, see the cysts accumulating in the lining pond here. But lining ponds are expensive, so we're trying to find easier, cheaper solutions for farmers. And this is the underground water pump where the farmers don't have to use any pumps. The salinity was low at the time, but now it has increased. So we have, besides Artemia, we have other creatures here. But right now the salinity has went to 110 degrees, 110 grams per liter. So there are no other creatures besides Artemia. Okay, that's it. Thank you.